So, good afternoon, folks. My name is Ken Rose, and I will be your MC for the remaining talks this afternoon. Please feel free to engage in conversations with other participants in the chat window in Whova. A couple quick notes here. If you have any questions, please put them in the Q&A window in Whova. The presenter will either address them during the presentation or live after the video if time allows. This session is being recorded and will be available at a later date on the Code4Lib website, on Code4Lib's YouTube channel, pardon me. Stay tuned after these talks for some very important announcements, as well as some words about Code4Lib 2022. You don't want to miss that. So first up, we have Edwin Spur, and his talk is Looking Beyond the List, Enhancing Search and Interactive Visualizations. Edwin.
Hi, my name is Ed Spur, and I'm the Clinical Information Librarian at the Augusta University, University of Georgia Medical Partnership here in Athens, Georgia. I'd like to spend a few minutes to discuss how visualization techniques can be used to display and contextualize the results in our collections. I'm also going to do a little bit of a demonstration of an application I developed called Collection View. Now here's an example of a very large, fairly heterogeneous database, the main interface for searching the Library of Congress. Now if we were to do a search for a random term, let's say in this case, pandemic, we see that what we get back is this very long list of results. So long they have to paginate it. It's over 7,000 results. And really this ordered list is the main access point we have to all of these results in this database. Now the Library of Congress is certainly not unique in terms of having this kind of interface. Indeed, the ordered list is probably the most common interface technique used for all of our systems, from bibliographic databases to our catalogs. Even the general purpose search engines that our users are most familiar with all present their results primarily as an ordered list. Now let's do some things pretty well. First off, because they're so ubiquitous, most of our users already understand how they work. Also, an ordered list does provide good access to those items that happen to be visible on the screen at a given time. When you see a hot link, you can click straight through. However, lists do have some disadvantages as well. The primary one is they're only ordered along one axis. Whether we're talking about data publication or about presumed relevance to the searcher, the only real information about an item that we have is its position on that list. Perhaps most importantly, lists don't do very much in terms of showing the context for a given search or how the different parts of a complex search relate to one another. Now the reason we have to be concerned with what lists do well and what they don't do well is because our users approach our systems with very different tasks in mind. Now sometimes users approach with fairly simple searches. They're looking for a known item, or they're looking for 4 or 5 good references for a class. But sometimes they have broader ideas in mind, like trying to browse an entire collection to see if it's worth looking at more closely, or doing very rigorous, complicated searching that you might do for a systematic review. In these cases, we really have to be cognizant of what our systems do well and what they don't. Now, many times when we think about complex searching, we think about it being an iterative process. And certainly that's the way we often teach it in bibliographic instruction classes. We approach it with the idea that a user is very unlikely to light upon the perfect search the very first time out. Instead, you're going to have to look at what you get back, figure out if it's not enough stuff, figure out if it's too much stuff, figure out if it's the wrong stuff altogether. You're going to have to change your search strategy. And indeed, the expectation is that a user might have to change their search strategy 2 or 3 or 4 more times until they get it dialed in the way they want it. Now, the limitations of lists really become an issue when we start using this method. Because if all we have to go on in terms of how well our search is working is the total number of search results, or that tiny window of results that happen to be in the screen at a given time, that might not be enough information. Now, if we're to take a closer look at those results in the Library of Congress, we do see one potentially pretty informative thing. We do have some facets on the left-hand side. And again, these kinds of information scent marking can be seen in many different systems. And it gives us a little bit of context in that we can see how many items fall into each of these individual categories, topmost being the formats, the original formats of the items. Now, this is pretty helpful. It does give us information about things along more than one axis. And it is sometimes easy to see which number is bigger and smaller. But I would argue that when we see lots of these numbers stacked up next to each other, it becomes a perceptual challenge. It's kind of hard to see which number is exactly bigger or smaller than another one and how those numbers relate. Now, if we take that very same information and repurpose it as a visualization, in this case a stacked bar graph, we have a better sense of how those different formats compare to one another. So again, just like with that list of numbers on the left-hand side, we can easily see that photos, prints, and drawings make up the largest portion of the total results set. But we can also see that books and web pages are pretty close behind, and that there's a very big drop between legislation and the other format types. Now, it's important to note that all of the information from that original web page, whether the long list or the numbers from the facets themselves, are also available from this API at the Library of Congress maintained by LC Labs. And this is important because since this data is available through this API, we can talk to it programmatically and construct visualizations to our heart's content. And indeed, we're going to spend a little bit of time looking at an application that I put together called Collection View. You can find it at this URL that does exactly that. Now, before I demonstrate the application, I do want to talk a little bit more about visualizations. Now, certainly, I think it's arguable that one pro in terms of using visualizations is they do a much better job of summarizing complex data than lists do. We have a snapshot view instead of having to troll through an entire list. And also, if we could find a way to do an interactive visualization, we could theoretically show how changes in search strategy affect what's going on in real time. Of course, the big disadvantage to a visualization is that it's not as simple as a list. Many times we might have to explain to a user what's going on. Now, when using visualization techniques to describe and contextualize search results, we're taking advantage of two big properties of items in these kinds of databases. First off, the notion that items have discrete attributes. So we can talk about the format of an item, or the date of an item, or maybe the subjects that an item is indexed under. And all of these things are groupable, so we can comprise individual portions of a search and graph those out. But also searches themselves make sets. So we can compare different result sizes from different search results. We can also talk about relationships between one group of results and another. So if we take a look at Collection View, we do see that we have that initial visualization of the different formats available for a given search. But we can also think about taking a complicated search and breaking it down into constituent parts and taking a look at how those individual parts relate to one another. So we could also think about the two eternal verities of death and taxes. And we'll try to see if there's some sort of relationship between those individual pieces of this broader search. And sure enough, if we go down and we wait just a minute for this to load, we can see that indeed, unsurprisingly, since this database is something that has a lot of legislation in it, there is a good bit of stuff about taxation. And there's also a fairly good bit of stuff about death as well. But what I personally find kind of surprising is this pretty large overlap between these two different sets. And again, this is the kind of insight that's available when we use this sort of visualization technique. Now, besides graphing the relationship between individual sets and doing visualizations of the raw numbers of search results in different formats, it's also worthwhile thinking about the baseline of the collection itself. Here's a quote from Edward Tufte, because of course it's a lecture about visualization and where would we be without Edward Tufte. But this really brings home the idea that we have to think about baselines when we're thinking about comparisons, because comparisons are oftentimes where we can sort of glean information from these visualizations. So if you think back to that slide before, when we took a look at that pretty large section under web pages for our pandemic search, well, we know that there was a lot of items for that search, but what that doesn't tell us is whether or not, that is something that is unusual in any way, shape, or form. Maybe there's always a lot of web pages in all the searches. Only by comparing to the collection as a whole can we actually see whether or not this is the case. So if we're to go back to our pandemic search, we're to scroll down just a little bit to our proportional graphs, we can see that sure enough, in proportional terms compared to the collection as a whole, that is an unusual number of web pages. It's also a fairly unusual number, an unusual proportion of photos, prints, and drawings. Legislation, also kind of unsurprisingly, that's a topic that people are pretty concerned with nowadays, and a relatively low number of books coming back from that search. By the same token, we can take a look at our year readout as well, because that's another one of those facets that's generally available for most searches. And we can see by century, the current century comes out well ahead of any other century in the database in terms of results for the term pandemic. So something we don't see so often with our online catalogs, but is actually pretty common in big bibliographic databases like PubMed, is this notion of tracking search strategies. Again, to facilitate that notion of iterated searching, trying to dial in the perfect search strategy. So certainly over the past several months, many of us have paid more attention to bird life than maybe we had before. So we could take a look at the catalog and say, well, I want to look at things about jays and larks, and I'll go ahead and throw in starlings as well. So we have 3 individual searches. And just as in our earlier example, where we're comparing parts of our complex search, we can actually compare these individual searches as well. So I'll go ahead and select all 3 of these and hit compare. And if I scroll down, I notice a couple of different things. First off, poor starlings. Apparently nobody cares about starlings, but also there seems to be a lot more stuff about jays than the other 2 birds. And indeed, that stuff seems to be a lot more heterogeneous in terms of formats. And again, if we look at our Venn diagram, we can see that that circle for jays is a bit larger than all of the other circles as well. And indeed, if we were to take a look at a search of jays in the Library of Congress system, we would see that, oddly enough, there are a lot of people named Jay, a lot of legislation that comes up when we use the search term Jay. So we have to regroup and change our search accordingly. So if we're to go back and clean up our search a little bit by doing jays and bird and larks and bird, we might be able to see whether or not this makes sense in terms of really getting us to those bird items as opposed to everything else there might be. So I'll try compare. Again, starlings kind of left out in the cold, but it does look like those searches are a little more congruent the way I would expect them to be, instead of jays sitting out there by themselves. So, just as it can be helpful in terms of visualizing raw numbers of items for each format, as well as the relationships between different sets, sometimes those proportional graphs can really help us check our work as well. So for example, I'm going to do a search for operating system. I do that search, I get back these formats. You know, see a lot of newspapers sometimes with some of these searches, so maybe that doesn't surprise me so much. Maybe expect to see a little more in the way of books. So yes, newspapers up, books down. But then if I go down to my century proportional graph, see something that's kind of troubling. I'm not really sure if there's operating system on the Watt steam engine, but it's just really not what I would expect to see in terms of a higher proportion of things being from the 1800s through the 1899. So let's try to tighten that search up a little bit and see if we can get it to make sense. So if instead I were to do that same search string in quotation marks, make it a little bit more specific, indeed, it gets to be a smaller search, and more importantly, those centuries make a lot more sense. As I noted before, Collection View gets its data from that Library of Congress API maintained and developed by LC Labs. It's basically a browser-based application, so written in JavaScript with a little bit of jQuery and Bootstrap thrown in. And in terms of visualization, it uses Google Charts as well as Ben Frederickson's excellent overlay of D3JS, then.js. This is a live application. Currently lives at espr.github.io/collection-view. Feel free to bang on it. Please feel free to let me have any feedback, any enhancement requests, any critiques. Be gentle, it's a work in progress. If you want to see the source for this application, you can find it on my GitHub page, github.com/espur/collection-view. So as I said before, this iteration of Collection View enables us to explore the collections of the Library of Congress. But of course, these same techniques could be used for other databases as well. And indeed, if you were to navigate over to searchworkbench.info, you would see similar work that have been doing visualizing results from PubMed. So that's the end of my presentation. Here at the virtual meeting, I'll be in the Whova platform to take questions. But if you think of something later, or if you happen to be watching this presentation in a different venue other than during Code for Lib 2021, please don't hesitate to send me an email at espur@uga.edu. Thank you for your time.
And thank you for that presentation, Ed. I do see a new question here. Do you see collection managers and librarians using these tools to help inform collection management policies? Actually, looks like you may have answered here, but do you want to chime in on that?
Definitely. So certainly in terms of thinking of looking at searches as aggregates, that's probably one of the use cases that makes the most sense. Just sort of getting a 30,000-foot view in terms of the kind of stuff that lives in our collections. See if we can see, hey, where are we doing really well? Where's maybe some holes? And again, just that notion of thinking about search results as these sorts of amorphous masses of things, instead of just thinking about how to get to individual items.
Excellent. I'm looking here to see if there's anything else. It doesn't look like there is. So with that, I will say thank you, Ed, for that excellent presentation. We appreciate it.
Well,
And
thanks a lot, y'all.
Yep, we will move on. If you want to continue the conversation with Ed, you can talk to him in the chat in the Whova platform. Just make sure you're in that presentation part of the Whova, and we'll move on to the next talk, which is Alexandria Kalika, visually exploring current events and social justice patterns and WorldCat records data. It sounds really interesting. Alexandria.
Hello, my name is Alexandria Kalika, and I'm a senior software engineer at OCLC. Today I will be giving a talk called Visually Exploring Current Events and Social Justice Patterns and WorldCat Data. Let's begin. So, data. The purpose of this whole thing was I wanted to see how trends and holdings data reflect bestseller book trends. I wanted to see if there's a way to help libraries serve their communities by highlighting trends in popular relevant materials, and then trying to see what kind of different visualization techniques can I use to spot different types of patterns. So this is where it all started. It is very subjective, so I want you to keep that in mind because this kind of informs and influences the type of data that I have chosen. Last year, 2020, a lot of stuff was going on, pandemic, as well as Black Lives Matter protests were happening everywhere. But what I started seeing also that people were really interested in reading about racism, and it was making the news. The top bestseller lists were reflective of that, and also a lot of news stories were kind of showing how people really wanted to find books and read about this topic. And so this kind of sparked my interest. I was trying to see, like, is there a way that I can find trends in this data that we have? So this is just some of the technologies that I have used. Python, we have Hadoop cluster, I use Snowflake to transform some data, RStudio for machine learning, and Tableau for visualization. I think we all know that our data is pretty hard, so it's kind of this is just all the stuff that I've used trying to make sense of it a little bit. The subject headings in subject field 650 that I've picked were racism, Black Lives Matter, and police brutality. selected popular writers from bestseller lists in the news, and then popular titles, types of libraries, material types. You'll see those as well. All the numbers that you'll see, please keep in mind that provisional. This is kind of a proof of concept that I was trying to do and see. This was all about trends. Can I see trends in our data and relate them to current events? And current events being just a lot of marches and anti-police brutality marches, and a lot of interest in anti-racism literature. So the first thing I'm going to cover a little bit is how I've used machine learning a little bit, and kind of all the challenges and just some stuff that I've discovered and just something to consider, and maybe we can have a discussion about that. Challenges. Our data, bibliographic data, is not traditional data. A record about a book is not traditional, and you can see that in a lot of the machine learning examples that if you've ever tried to do any tutorials, there's a lot of data that's it's focused on numbers, it's focused on sales, it's grades, it's very straightforward. However, we have a lot of data, and it's metadata about something, and there's a lot of it. So cleansing, finding, refining data requires a lot of knowledge, very specialized knowledge, because you have to know what that field means, what that subfield means, where it can be found, why is it there. And so there's always a question of if there are biases in the data, since a lot of people contribute to it. And this is all a work in progress, so there's a lot of disclaimers here in terms of that. So machine learning. Complexity of data is definitely a factor for this, because this means factors. If you read anything about machine learning, I've tried some of the tutorials, it will tell you that you will see immediately there's a lot of factors in the data. So, but if you reduce the factors, means you're making a decision of which field and which subfield is important, and that gets into kind of like technological accuracy dilemma, because what fields are you excluding and why? And there's a lot of different ways of doing this as well, so that makes it into the complexity. It makes it a complex problem as well. If you don't reduce the factors, you end up with hundreds of columns of data, which then makes it a little bit hard to kind of keep track of which variable is important versus not. So I'm going to show you an example of classification tree. This was just something that I could see, something I could use to see data a little bit clearly. Again, this is just a proof of concept. There's academic, public, and technical community colleges, libraries. That's what the letters on the very bottom stand for. And so this is a decision tree example. It's supervised learning, it's a classification algorithm, and it's kind of predicts kind of the likely held material type by type of library. Just kind of an overview. I've used Library Party Kit. RStudio was my friend for this. And this is just, so out of all different fields and subfields and different things, I could see some patterns. I could see that there is differences between print book and digital, and which libraries hold what. So it kind of shows that there is a way to spot patterns with this. Overrepresentation in data, though, can become a problem, because we do work with a lot of academic libraries. That's the data that we have. And it's kind of, then you have to also do kind of cost analysis of effort of extracting, transforming, and loading this data versus kind of doing the machine learning to try to find insights and try to figure out appropriate questions. This is not the best picture for a PowerPoint, but this is just an example of a decision tree, and I was looking at very specific authors, very specific library types, and very specific material types. And this just shows the complexity of our data. We have all this stuff, and trying to make kind of predictions or patterns about it is like we have a lot of variables in our data. And this is just some of it. So, and this is extremely small slice of it. So I just wanted to see if I could see patterns, if I could see something about library types and material types and which authors are more likely to be represented. So this is kind of what I did with this slide. Um, Visualizing data can also be done a different way, so I decided to look at different trends. And for this, I used Tableau. So I looked at material types, digital versus print, library types, academic, public, school, and community college. And then I looked at authors, titles, and holdings data, 2019 versus 2020. So 2019, it was pre-pandemic, before the protests, I mean, there were protests, but they weren't to the extent that they were in 2020. And then ethics, kind of, we have to think of like historical data, what happens with controversial artists. So I looked at a lot of data based on top bestseller lists, but what if the author as deemed by people who are topic expert, deemed controversial or maybe not as correct as they were. And also topic authority. I am not a topic authority on these subject headings. This was just to spot trends based on what I saw in the news. The first one, I loaded some data about subject heading racism. So I wanted to see first what kind of libraries held this data and if there were any changes. If there were any changes based on year to year, but also digital versus print, because I mean, last year, pandemic, so how people were interacting with libraries was changing. A lot of people were turning to digital copies of books. So I wanted to see, is this showing up the same in the subjects that I have chosen for this? And there is a rise in definitely in digital holdings, and there is a rise over um, many different types of libraries. So then I wanted to see, who are these artists? Who are these authors that are writing these books? And can I see some sort of change in what's happening? What's happening with their popularity from just our holdings data? Is there anything interesting? And I did see that, especially in the digital space. If you look at the digital holdings, there is new writers coming up. There is different people bubbling up to the surface as the holdings of their digital copies of their books are actually pretty substantial. So that was interesting to see, and that was kind of cool, and that's what I was looking for, like trying to see, okay, so there is a rise and there is a trend to getting more digital material by these authors with this subject heading. So then I wanted to see police brutality as well. Also, same thing, I could see in the author, different authors are bubbling up in 2020. Different authors are in the digital space versus the print space. So it was also cool to see that you can see specific authors kind of becoming more popular. And that might require further study, especially considering it seems like the numbers grew up dramatically, and for some of them. And so that's something that I thought would be extremely interesting to kind of understand, to figure out what was driving that demand. Then I looked at Black Lives Matter. It's a reasonably new tag, so but it still had similar patterns. There was a rise in digital content in the year 2020. So then I decided to focus my data a little bit on popular authors. So when I looked at the New York Times bestseller lists, there's different authors that were popping up and were interesting to me. So this is also subjective data. So obviously, if this is kind of talks to how we need to define what popular is, what is popularity, what is kind of what should bubble up to the top. Um, and so I decided to just pick these 5 authors and see what can our data tell us about them. They are obviously popular. They're showing up on New York Times bestseller lists. So what are their trends? So these popular creators, I was able to see that it was actually a more dramatic kind of change, especially in digital space. So just these five authors that I've picked, some of them were not digital at all. Didn't have any digital presence in any libraries that we have data from. So it was interesting to see that like two of the authors all of a sudden had digital presence in 2020 in the libraries, and some had dramatic increase in their print books as well. So it definitely shows there's patterns. There could be something interesting there that we can see, and something that we can highlight to libraries and see if they find these trends interesting. This just shows kind of a different way that these authors are and just a huge difference of digital versus print presence for two of these new authors. So the more I thought about it, of course, there's ethics of popularity trends. Like, who can classify popularity? Is it the bestseller list? Is it how many holdings a library has? That could get tricky. What about controversial authors? When people who are authorities in certain topics, what if they start pointing out that some of these authors that are very popular and sell a lot of books are problematic? Kind of, how does one deal with data like this? This is just some of the questions I kept thinking about. And just the rise of digital content. I thought that was very important because it can show like accessibility of data, but only if you have computer access, if you have digital technology to access the books and the information. So here are my conclusions. There's definitely patterns in the data. There's different patterns, different trends. Machine learning has a potential to find trends and patterns to help libraries in highlighting um, what works in demand if used properly and with deep understanding of the data. And analysis of print versus digital work shows that there is a trend that can reveal accessibility of materials, and that can it can reveal that materials are becoming more accessible because the more digital content is, it means like people don't have to go directly to the library. They can access this content from their devices, but that also implies they have the devices to access this data. And I think that is very important to consider when looking at the trends in the material type space, because while it's awesome that there is so much more digital content, we have to make sure that the readers have the ability to access this kind of content. Future data works, I'm definitely looking forward to looking more at this, more understanding as to where geographically a holding is located. This is something that proved a little bit problematic and kind of harder to find than I thought. So I would like to look in that a little bit more, and more refined visual representation of titles based on current events. Is there something else besides bestseller lists? Is there a better way to represent this data than I have shown? And I'm sure there is. How can I show the trends, the patterns, so that it's useful and understandable to people that might be interested in this type of data, and seeing change over time in topics, interest based on holdings data. So if I go back, I have to see if I can, back from 2019 or 2017 or whatever year, what does it tell us? And some of the stuff, it becomes kind of a question of data accessibility, data access, and data availability, because Black Lives Matter subject heading is pretty recent. So it's kind of like trying to understand a little bit what does that mean for data visualization and for data representation. Thank you very much. Again, my name is Alexandria Kalika. I work for OCLC in the research department. And if you have any questions, please let me know. If you have any more questions about my work, please reach out. Thank you so much for listening to my talk.
And thank you for your presentation, Alexandria. No questions came in that I was able to see, but I was looking at the poll you created. Do you use machine learning in your work? And it's coming in at pretty much 90% no, 10% yes. I was just wondering, does that surprise you at all? Is that sort of what you were expecting? Just wanted to get your thoughts on your poll results.
I think it was interesting for me to see that because I think machine learning has become like super hot and trendy. Keep like it's like the big word now, like to use for everything. So it was interesting to see that there is, I mean, but it was kind of cool to see there is some, you know, some representation for that. But yeah, sorry, my laptop is doing weird things, so I can't even start my video. This is like
Well, you sound crystal clear, so.
okay, cool. Yay. At least something works. Hooray. But yeah, so it was interesting to see, and it's kind of good to know that it's like it's not something that's widely used, but there are people that are definitely using it in their work. So that was kind of cool.
Okay, excellent. We can open it up for a couple questions if anybody has one. She's here to answer. If you have some questions later, you can go back to the chat or on Slack. We'll give you a couple seconds, give some people a couple seconds to chime in. If not, we will move on to the next talk. And I'm not seeing anything. From Eric Pugh, which tools were most useful?
The current thing that we just got some of the licenses for Tableau, so that became super useful, and that became super. Then it's like you can kind of look into the data. Like our data is weird; it's in like an XML like tags, and it doesn't look like very pretty. So as soon as you're able to pull that out and then put it in Tableau, it's like bam, you're like immediately. It's like immediately like you can spot like trends, you can spot just all kinds of stuff. But yeah,
Yep, go ahead, Alexandria. I'm sorry.
yeah, there's a question, like there's a comment from Kate, and it's like, yeah, definitely, it's integrating machine learning with bibliographic data. It's like it's a hurdle because it's like you have to understand the data. There's a lot of data. There's a lot of categorical data, so it's not numbers. Like it's a lot of like descriptions and words, and that was also that's why it's a proof of concept of a proof of concept because it is hard to use for that. Like there is a barrier to entry definitely, and it's like, and you know, I'm a physics major, so it's like in the past, so it's like it should be easier, but it's understanding the data is so much more than just like knowing some math and techniques.
Okay.
Okay.
Well, thanks again, Alexandria. That was a excellent presentation. Does somebody have something? I thought I heard somebody trying to chime in. So if not, thank you again, and we will move on to the next presentation. Up next, we have Eric Pugh on how to measure diversity in search results. And just a little bit of a heads up, this recording does have some background sound, so you may have to adjust your volume accordingly in order to make it sound better. So I wanted to mention that briefly.
Welcome everybody, and thank you very much for coming to my session on how to measure the diversity of your search results. I hang out on the #Blacklight channel of the Code for Libs Slack, so come find me there. I'd like to make a thank you to the folks who gave me this idea for this talk. I got to work with Jeff Campbell, Harry Scheiket, and the team working on the Lux project at Yale last year, and we had some really interesting discussions about the differences between someone who's looking for a specific answer and knows what that answer is looking for, and someone who is really researching a topic and is looking for, you know, what is the breadth of options available. That was the first time I really started thinking about this, and this talk comes out of some of that thinking. Search can be thought of as a struggle between precision and recall. Now, recall, for those of you who aren't familiar with it, with that term, is a measurement of how much you're returning all the documents that might be about a specific query. When you focus on recall, you're trying to return everything about a topic. And typically, you're going to see a lot more search results returned. This desire is very common in research use cases. In contrast to that, we have precision. Precision is all about just give me the answer. I'm looking for a specific document, a specific result. There's one thing that answers what I'm looking for, so let me just find it. And I think that the best expressions of how precision works is using Siri. Let's find the website for Code for Lib. Siri, what is the website for the 2021 Code for Lib conference?
I found this on the web.
And if you look very carefully, you'll see the very first search result is the URL for Code for Lib 2021. Siri is a great example of a search engine based on voice that's really built around wanting precision. Now, classically in search, we have a lot of different metrics that help us understand, are we getting everything back or are we tilted towards precision? There's a lot of tooling out there as well to support that. For example, I steward a project called Cupid. Play on Give Your Queries Some Love. And it's an open source project that lets us understand and tune the quality of our search results. So in this screen capture, you can see that we have a 0 to 3 rating, right? A 3 is a perfect movie for that query, and a 0 is a terrible movie. And a 2 is relevant, and a 1 is maybe. Like, I see why it came back, but I wasn't looking for it. And so there you can see it, right? The original Star Wars got a 3. Battlestar Wars got a 0 because it has nothing to do with Star Wars. The Star Wars franchise just happens to share some words. Star Wars spoofs, yes, technically it's somewhat related, but I wasn't looking for that. Star Wars The Clone Wars, yeah, that's one of the major properties, right? So we have tools for measuring precision and accuracy. And traditionally what we've done, and where I've sort of focused professionally, is trying to change the search results so that everything that I'm giving you for Star Wars is a 3. I want to show you all highly relevant results. And I just focus on that, and I try to give you really great results. But that is doing our users a disservice, because maybe we're actually giving them exactly what they asked for, but that's not really what they wanted. So let's take a segue over to the world of e-commerce search optimization, where there's a lot of innovation in improving search. So this slide is courtesy of Andreas Wagner, CTO of Commerce Experts, a German firm that focuses on optimizing e-commerce, and gave an amazing talk on measuring e-commerce findability. And he said, you know, this is a pretty typical thing, right? I am searching for bicycles. And which is the better set of results? The one on the left with a bunch of bicycles, or the one on the right that has bicycles but also has a lot of garbage in there? And Andreas and his team had done a lot of research on what actually happens in the real world when different users are presented with this. Now, obviously, if we're focused on precision, the query on the left is definitely more precise. Those are all bicycles. Maybe if we care about recall more, then the query on the right maybe looks a little bit better. I mean, it's bicycles, but it's also bicycle-related paraphernalia. So, if you're running an e-commerce search engine, which of these two do you think would convert better in the e-commerce world? Which do you think is going to attract more clicks and eventually more purchases? Well, if you guess the one on the left, which is the one that the experts all rated as all being highly rated documents, right? They all got a 5, the highest rating. Whereas over on the right, the average rating was a 2, right? 3 bicycles getting 5s, but those other products were much lower. And yet, look, we got 21% more clicks for the set of results shown on the right, and we got 17% more gross margin volume, the results on the right, more than they liked the results on the left, even though, according to our rating algorithm, tools like Cupid would have suggested that the one on the left was the best. Now let's think about that, right? I think that makes sort of intuitive sense to all of you out there, because as human beings, we value diversity. We recognize that honestly those results on the left are a sterile monoculture of results, and that while technically accurate, especially if you think the way a machine would think, it's definitely not as helpful to us as humans. The results on the right help remind me, yes, I need a bicycle, but look at these other products that I also need. I need a helmet. If I'm going to ride at night, I need a light. I need a kickstand. I didn't know that there was, specific clothing I might be interested in. You can see why what's on the right makes sense. Now, I do want to point out there's some pretty next level search optimization going on in that right. For example, they made sure that the thing that was closest to the query, the bicycles, show up at the top. And they're sort of nicely grouped together, so it sort of makes sense. However, this begs the question, how do we put a number on the diversity of our search results? We all know that old saw that you can't improve what you can't measure. So I'm going to share one approach that I've been using to help me measure the diversity of my search results. So first off, I need to introduce the idea of entropy and how we're going to use it to understand diversity of search. In layman's terms, you describe entropy as a measure of uncertainty. And more specifically, we're going to use a variant called Shannon's entropy, which is named after Claude Shannon, the chap on the picture you can see, who is often considered the founder of information theory. I'm going to take you through a process of measuring diversity that is based on the idea that we want our documents that show up above the fold in our search results page, on the first page, where the user can see them, that we want them all to be from multiple different sources. We don't want them all to come from one source. If they all came from one source, then we would have an entropy of 0. We know with 100% certainty that they came from one source. However, in contrast, if we have 10 documents from 10 sources, then we have an entropy of 1. I tried to rewrite all of that in want more diversity, then you want more uncertainty, you want more entropy. Entropy good. Have very similar results, then it's very certain where they all came from, right? They all came, very similar results all came from the same source. That means very low entropy bad, okay? Because historically, I've always thought increasing entropy would be a bad thing. But it turns out in our use case for diversity, it's a good thing. Let's see if we can look at this visually by looking at the search results for the query Mark Twain at the Library of Congress through the lens of the original formats of the works that are archived at the library. So Mark Twain was a newspaper man, so when we look, it makes sense that there's lots of search results for that query. He also wrote some rather important books. It also turns out Mark Twain has been referenced in many other works of art. The term Mark Twain shows up in maps. Mark Twain National Forest. There's a musical after Mark Twain. So lots of different things about Mark Twain. The other interesting thing about this website here is that it has this idea of available online and all items. And interestingly, they both pretty much look like 37,000 documents available online out of a total of 40,000. So I was playing around with the query and kind of wondering what's the difference and what do we get back, especially because the total numbers seem pretty similar. I expected the same documents to come back whether I wanted them online or all, right? And so I went ahead and looked, and there is, for available online, a long screenshot chopped up, lots of different things. We got some web pages, we got some photos, we've got some books, printed materials, notated music, right? Pretty wide variety of documents of those original type documents. So I'm assuming relatively high diversity. I'm hoping to put a number on it. But then I tried the all items just to see what the difference was. And I was actually really surprised because it was all books. Like, wait, where did the web pages go? Where did the other, the algorithm being used. Same query, more or less the same data set, right? 37, 40,000 seemed the same to me, but it appears that what's being returned is very different. So let's go ahead and just do a little bit of math. Let's use Shannon's entropy and try to understand the diversity of those two result sets. Now, this link here is a bit.ly link to a Google spreadsheet, bit.ly/code for lib-measure-diversity, and it's set up as a template, so you can go ahead and open it up and play with it as well. So the idea behind this, and I'll keep this as a high level as I can, is that we basically go through all of our search results, and we're not focused on whether these were good or bad search results. It's really, we're focused on the diversity. So we went ahead and I did the all Library of Congress, and notice we have book in position 1, the very first result. Second one is a photo. Third one is a book. Fourth one is a photo. But then we go and everything is a book. We are sourcing all those results. We finally get a web page and then another photo in the first page's worth of results. So the concept here is we're going to go ahead and take those and we map them to our categories. And when we look at this, out of our 24 terms, we have 20 books, 1 web page, 3 photos. And this count ratio column is sort of giving it in percentages. 83% of our results are book and printed material. 13% are our photos. There's some normalization math going on in columns F and G. And then at the end of this, we calculate our entropy. This is Shannon's entropy. 0 meaning there was no diversity, and the higher the number, meaning higher diversity. And so this number that we're getting is 0.78. That's, not that far from 0. We did not have very diverse results. And it gives us a number so that as if we want to mess around with our algorithm, we can see whether we're both improving the quality of our individual search results, but also pulling in more of the content from the different repositories or the different types of content. So here's one example. But let's go ahead and look at that online one. It's a little bit different. Now, intuitively, we definitely feel like that entropy score is going to be higher, which means there's more diversity in our search results. We did the same process of going through and saying, in position 1, it was a photo. Position 2 was another photo. Hey, look at this. Position 3, a web page. Some more photos, another web page. We have some film, we have some notated music, some more notated music, some more web pages, some more, right? We're seeing right here, just looking at the raw data, we can suspect that it's going to be more diverse. So now let's look at our roll-up. Out of our 24 results, we had only 1 this time. The algorithm is wildly different. Only 1 book or printed material, but 9 web pages, 10 photos, print, film, 3 notated music. We're still not amazing. I mean, there are audio recordings out there. There is legislation or periodicals, newspaper articles. It's interesting that there was a huge number of Mark Twain related newspaper articles, yet none of them show up on the first page. But if we look at our percentages, it's a little more diverse. And if we go through our math algorithm right here, and end up here, we see that our entropy is 1.81. It's significantly higher, more than double so. That there gives us a worksheet that gives us a tool for letting us look at diversity. We, in this example here, we picked the origin of documents, what the original format was. But we could have done this for different sources like libraries holding collections of information. We could have done that on. We could have maybe chosen time periods. We could have, anything that you want, you can apply the same basic process. We also only did it for 1 query, but you can take the same process and have many queries and then sort of sum up the entropy over a whole set of queries. So I want to thank you very much. Let's compare notes. I'm really curious if other people get some value out of this. As I said, find me on Pound Blacklight on codeforlib.slack.org or email me at epu at Open Source Connection. Thank you very much.
And thank you for that presentation. I see there's a lot of conversation going on both in the Whova platform and in Slack. Since we are at the end of our time for this presentation, feel free to keep those conversations going, but we will need to move to the next presentation, the next presenter. And this is going to be Brian Fu, digging in our collective crates of sounds. And before we start this, I do want to tell folks that this presentation heavily uses sound and music. So you want to adjust your volume accordingly, maybe keep it down to begin with and adjust it as you see fit moving forward. So with that being said, we can go ahead and start the next presentation.
Hey everybody, my name is Brian Fu, and today I'll be talking about how we can use hip hop and the metaphor of the DJ and crate digging to make audio and video collections more accessible and reusable to the public. So this project that I'm going to talk about, which is called Citizen DJ, it was part of a year-long residency at the Library of Congress, hosted by LC Labs, which is part of their digital strategy. And I encourage you to check out their website to see other projects that really think about how to innovate using their digital collections and think about new ways to access and reuse their collections with new audiences. So a brief introduction to myself. So I'm a computer scientist and visual artist, and I've worked at libraries and museums for about a decade. And I'm also a lifelong b-boy or breakdancer. So this is a photo of me about 30 years ago doing a routine with my buddy, and then a more recent photo of me doing some moves in the library's halls before the pandemic started. So that kind of segues into really the main inspiration for this project. It is really centered around the history and culture of hip hop, and I've particularly drawn to a moment in hip hop, and this is when I started to listen to music in general in the early 90s, where you have kind of this golden period of hip hop. This is particularly enabled by technology that really allows producers and DJs to really use sampling in new ways using existing sounds. And this created landmark albums from De La Soul and Public Enemy that these albums were made up of hundreds of samples into these really dense sonic collages that are historically and culturally significant unto itself. And I was really inspired by this idea of a DJ as this collector of sounds, where they would literally be digging through crates in the basement of record stores or thrift shops and flea markets, trying to find the diamond in the rough, some unique sounds from other eras and other genres to amass this huge personal collection of eclectic and rare sounds that they can remix into something completely new and their own. So they're very much kind of like their own archivist, and being able to recall certain sounds at any given moment to mix into a live performance. So this really was the basis of my motivation on thinking about how to really think of what is in our collective crate of sounds, as a country or as just a citizen of the world. What are sounds that belong to all of us, that we can reuse and create new music for free and without restriction. So I wanted to work with the institution, an institution like the Library of Congress, to really think about this from kind of a holistic point of view. And I had the privilege of working with folks at the Library of Congress across all the different departments to try to identify what sounds are completely free to use and reuse from a music making perspective. So I'm actually just going to jump into the actual tool that I developed, and actually most of my presentation will kind of be on this particular website. So this is completely free and public and open to use on the internet. I'll have a link to it at the end of the presentation. But this website basically presents 8 collections of audio and video materials that have been identified as completely free to use and reuse without restriction. And this is a really long process, but I had the privilege to work with folks at the Library of Congress to really think about this from all different angles. So the first thing I asked from various managers of different collections is, what are some culturally significant audio and video materials that the Library of Congress has that the public doesn't really know about or is underutilized for whatever reason. I was also interested in trying to get a really good diversity of different types of sounds. So in addition to music, thinking about how there might be some oral histories or radio or government film that might be interesting to use and reuse, as well as sounds from all different eras. So really old sounds all the way up to contemporary sounds. I won't get too much into the weeds, but copyright is a huge aspect of this project, and I'll talk about it a little bit later. But the big thing is that music in particular has a lot of different layers of copyright, especially more contemporary sound recordings of music. So there's often many different layers and considerations when you think about audio. So and in particular music. So you have the the person who wrote the song, the person who performed the song. In the cases of field recordings, the person who collected the song. So yeah, here you'll be able to browse 8 of those collections that we found, and they're from all different eras, all different genres. We have radio, music, oral histories, government film, and they're from all different eras. So we have things from the early 20th century, some of the oldest recorded sounds. We have some contemporary sounds that are from the last decade, and I'm just going to jump into them. So the strategy that I took when trying to think about how to create interfaces to explore and reuse this audio was kind of going back to that metaphor of crate digging, and really having the end user in mind, and that is in particular a producer or musician who is interested in sample-based music making. So it's a relatively narrow end user, even though I feel other people of other types of users would find this compelling and interesting and useful. But really starting with this idea of what is the kind of the next step or the next evolution of crate digging, and hip hop is very much technology driven. A lot of the creativity comes from innovative use of existing technologies. So I'm just going to jump into one of the audio collections. So this particular collection right here, it's a collection of fairly old records from the Edison companies. So this dates back to the early 20th century. This is some of the first recordings that were made available on plastic discs. So these are the predecessors to kind of what you think of a vinyl or turntable records. So each of these collections often contain hundreds, if not thousands, of hours of audio. So the first thing that I wanted the user to be able to do is just really get a sense of what is in this collection sonically, and do it very quickly and intuitively. So basically what you see here is about a little over 4,000 audio clips that are representative of hundreds of hours of audio in this particular collection. So you could use your cursor to drag through the audio, and you can hear these sound clips as I do that. So I'll quickly do that. So you can imagine, the traditional user interface of audio is, your typical search interface where you would either be browsing or searching using facets, and you would click on an item and then you would listen to it. This really allows you to very, very quickly just listen to the kind of the sonic quality that's embedded in this particular collection. And again, having the end user of an artist or a musician or a producer in mind, where in addition to kind of the content and the subject matter, they're also interested in kind of the aesthetic quality of the sound. So in this case, you could kind of hear it's this very vintage quality. It has a mixture of music and skits. And also the clips are organized by sonic similarity using machine learning. So if I scrub in a particular section, the sound should sound similar. So in this case, it sounds like it's all the opera got grouped together. And another section. Sounds a lot like the piano and xylophone. And then also there's some filters that you could use. So I make available some of the metadata from the Library of Congress. So these are some of the subject headings. So I can just highlight everything, let's say marked as humorous songs, and just play those. So it sounds a lot like skits. And again, in the mindset of a musician, I can highlight everything that was marked as a musical note of C. This is using just basic pitch detection. As well as I could just filter by pitch, so I could just highlight the lower pitch sounds. And just to kind of quickly give you a sense of the sonic diversity in the different collections. So what you hear now is this collection of really old sounds. We have another collection that's composed of interviews with legendary musicians from the Joe Smith collection. So it's mostly spoken word. And again, you could see kind of the groupings here. And you could see just based on the color, the types of different islands of sound that we have. So let's hear what this island sounds like. So it sounds like it grouped all of the S sounds in this area. Let's just do a couple more. So this collection is a collection of more contemporary sounds from the Free Music Archive. I'll just play what that sounds like. And let's just do one more, the Tony Schwartz collection. It's a very fascinating collection made up of a lot of different types of sounds recorded by Tony Schwartz, who was this very eclectic you know, collector of sounds and radio personality. So he would do everything from record construction sounds to do like interviews on the street, to you know, interviewing small children on the playground, and you know, street musicians, parades, all these things. So it's a really eclectic mix, and you kind of see that reflected in the visual here, where you see a lot of different islands that seem to be very different from each other. So let me quickly scrub through that. So I'm going to go back to the Edison collection. So as you can see here, as you scrub through, on the bottom, it tells you where this particular sound comes from, and I think this is a very important aspect. So if you find a particular sound, you could play it in context. And you could actually go back to the original, so you can see where. So this sound starts at about 1 minute and 8 seconds in, and I could view it on the library's website. And I could actually download the full audio here, and obviously see all the different metadata. And in addition to that, the fun thing is that once you find the sound that you like, you can go into this other interface to remix it. So what this did is that this took that sample and put it on this musical sequence and added some drums. But I'm going to mute the drums for now and just play what the samples sound like on this musical sequence. And then I could speed it up a little bit. And then drop the drums. And I could shuffle the drums. Edit the sequence. And I could even edit where the sample's coming from in the audio clip. And I could shuffle to a completely different sample. Make it into like a techno sound. And then from here you can download this particular pattern that you made, and again kind of go to the original source. So in this case, this sample comes from this longer excerpt. And you could go to the original audio source on the library's website and download the original source. And then one thing I want to quickly point out, on the top right here, there's a link to a guide for copyright and ethics around sampling. And this was a very important aspect of this project that I'd love to go into a little more. But this really just gives you a very clear and hopefully easy to understand guide to how you can use music for sampling. So this tells you how you can use the Library of Congress materials for this, as well as give you some resources for thinking about things like fair use, as well as ethical considerations for reuse. And this is particularly important around field recordings that might have been unpublished and might represent cultures that might not have sharing as part of their sound culture, as well as thinking about things like compensation. So there's a lot of great resources here for that. And then lastly, all of the code that made this interface is open source. So in theory, you should be able to kind of take the interface and take some of the Python scripts that I wrote to remix your own AV collections. And I would definitely like to hear if anybody is interested in doing that. And yeah, here are some links to the interface as well as the code repository. And I am over time, so thank you, and I look forward to hearing your questions.
Thank you. If you look at the feedback in both Slack and in Whova, people's minds are just completely blown. So thank you for that presentation, Brian. We are at the end of time for this, so you can continue the conversations in Whova or in Slack, but that was absolutely fantastic. So up next, we're going to have closing announcements. We're going to have the wrap up that includes closing announcements and then a shout out to the sponsorship folks. But first, before we get into those, we have Carlin Chase from University of Buffalo is going to talk about Code for Lib 22. Hey, Carlin.
Hello. So I'm sorry, I'm a little bit shy given the number of people that are on here, but I work at University of Buffalo, and this is my second Code for Lib. And we did have a proposal put forward last year. And, you know, as everybody knows, we bowed out for 2021 in the hopes that we could put forth a proposal for 2022. So we are still getting some new numbers and things. We are going to still present, if some people remember from last year, 4 scenarios, or maybe 5, actually 5 scenarios. Because we are trying to get a campus scenario that involves 2 different dates, March and May again, to bring costs down, essentially. We really want to make the conference more affordable if possible. It just involves a lot more moving parts with the university where I work and getting rooms booked and things like that way ahead of time. And we are going to offer a virtual option just in case. And we did pledge last year that if the community awarded us 2022, that we would host it and plan it regardless if it needed to be virtual or not. And that's pretty much it. We're just refreshing the proposal website and hoping to get the financial picture updated soon and get that link out to the community. So I think that's all I really have at this point.
Okay, well, thank you very much for that information. We look forward to seeing your updated proposals, and we'll see where the next year takes us. So some final announcements here before we close out for the Code for Lib Main Conference 2021. Tonight's the night to test your Mentalmite. There will be time to register. There's still time to register for Trivial Night, hosted by DC-based District Trivia through the Zoom registration link and the virtual meets thread on the Whova community board. Community support volunteers for tonight's trivia night are Mike Giarlo, Slack MJ Giarlo, one word, and Kate Lynch, Slack KAT3_DRX. The community support volunteers for tomorrow's morning and afternoon post-conference sessions are listed on our conduct and safety page on the Code for Lib 2021 website. So during the course of the day, there was a poll created that talked about like how many Code for Lib sessions have you attended? I just wanted to look at those results real quick. So we have 138 answers and about 40%, this is their first one. So that's exciting. It's exciting to get new people in here. And then for number 2, people who are attending their second Code for Lib, that's 17%, third, 13%. You can see the rest of the results if you go to the Whova page on the far left side. There's a link for polls, and that is one of the polls. How many Code for Libs? How many Code for Libs have you attended? So then there's that. So sponsorship thank yous. These are always very important. We'd like to thank our sponsors for their support this year. At the platinum level, we have OCLC and Blacklight. At the silver level, we have EBSCO, Innovative Interfaces, MIT Libraries, who are also our closed captioning and post-conference video production sponsor. At the bronze level, we have Performance Software Solutions featuring Fair Copy. We also have Princeton University, Developers for Diversity, our diversity sponsor, and then Princeton University, the institution, is our diversity sponsor. We also have Disability, Mental Health, and Accessibility in Libraries, their sponsor. We have Lyrasis as a bronze level sponsor. We also have Balsamic as our closed captioning sponsor. We also have Index Data as a bronze level sponsor. At the contributor level, we have the University of Illinois at Urbana-Champaign School of Information Sciences, and we have Saverna. So with that, we come to the close of our Code for Lib 2021, and we have post-conference sessions going on tomorrow. So with that, I would like to say thank you all for attending. I think this has been fantastic. I want to shout out the whole program committee, everybody who contributed to making this a success. And I will see you guys soon. Take care, everybody.